60 grams of a radioactive isotope was produced in an experiment. The rate of decay of this isotope is known and can be modelled by m is equal to 60 e to the negative 0.15 t, where m is the mass of the isotope in grams and t the time in hours. Find, to the nearest minute, when the mass of the isotope remaining is, first of all, 30 grams. Well, all we need to do is substitute m is 30 just here. So we have 30 is equal to 60 e to the negative 0.15 t, which you could simplify to e to the negative 0.15 t is equal to 0.5. At this stage, you really need to solve this using your class pad. So, action advanced solve. 30 equals 60 e to the negative 0.15 x, and we get 4.62. And of course that's in hours. And 0.62 times 60 gives us 37.2. So that is approximately 4 hours and 37 minutes. Then we're going to do the same thing for 10 grams. Just put 10 equals 60 e to the negative 0.15 t and solve on the class pad. So we'll just edit this one, make that a 10, and that's 11.945. And so I'll do 0.945 times 60, and that gives me 57 minutes. So we've got 11 hours and 57 minutes. We're now asked, what is the rate of decay initially and then when the mass is 30? Rate of decay means we need dm dt. Now we know that the exponential function just differentiates to itself, but that we need to also use the chain rule and so multiply by the differential of the inside function, which here is negative 0.15. That ends up being negative 9 e to the negative 0.15 t. Now, initially is when t equals 0. So dm dt, given that t equals 0, is going to be negative 9, since all of this will be 1 if t is equal to 0. And that's negative 9 grams per hour. And then when the mass is 30 grams, so we want dm dt, given that mass is equal to 30. Now we had the answer to that slightly earlier, and we had that the time was 4.62 hours. And I just retrieved that answer here on my calculator. So we've got t is equal to 4.62. And that is going to be, so what we're evaluating is negative 9 e to the negative 0.15 times the 4.62 and so on. So let's just calculate that. So I've got negative 9 times e to the negative 0.15 times this answer just here. And execute, and that is negative 4.5 grams per hour. Perhaps not a surprising result if we look at these two results together. So here and here, this is half the rate, and that's not surprising because at that point we have half of the initial mass.